As we know that Newton's laws state that if the particle has an acceleration, there must be a force responsible for it. For the case of uniform circular motion, when the particle has a centripetal acceleration, there must be a force causing this acceleration. If we take an example of a puck tied to a string, moving in a uniform circular motion on a frictionless surface, we can say that the free body diagram of the puck will have its weight and the normal reaction from the surface. But both these forces are perpendicular to the plane of motion. And as we know that the forces perpendicular to the plane of motion cannot alter the motion, thus they cannot be the reason of the centripetal acceleration. However, the tension in the string is the only force in the plane of motion, and thus should be responsible for the centripetal acceleration of the particle. This force will also be directed towards the center of the circle at every point, and hence is called the centripetal force. In this example, tension is said to act as the centripetal force. In this case, the normal reaction is acting as the centripetal force. In case of an orbiting satellite, gravitational force acts as the centripetal force. And what about this case, where a block is resting on a rotating rough surface? In this case, friction acts along the radial direction as the centripetal force to provide the required centripetal acceleration. Note that centripetal force is not a new type of force. It just means that the force acting on the particle is in this direction. Various forces, like tension, normal reaction, gravity, and friction, act as the centripetal force. Or we can say that they provide the required centripetal force. If particle has the mass m, and it is moving with speed v, then in all the cases, the centripetal acceleration of the particle will be equal to v squared by r, where r is the radius of the circle. And from Newton's second law, we can say that the centripetal force will be equal to the mass of particle into its acceleration. So the centripetal force on an object of mass m moving in a circle of radius r with uniform speed v is equal to mv squared by r. But now, if we consider these two situations, why is it that in one case the particle is moving like this, and in the other it is moving like this? That is, why does the particle move in a circle, in this case, and not in the direction of force? See, we never said that the particle should move in the direction of force. We always said that the particle has acceleration in the direction of force. If we take the example of an object that is slowing down, motion of the particle is not in the direction of force, but its acceleration is. If the particle was stationary, then its acceleration will be in the direction of motion, and thus the force and the motion of the particle will be in the same direction. But in this case, the particle already had some velocity, and the force starts to act in this direction. So though the force and acceleration have the same direction, but the motion of object and the force are in different directions. In case of circular motion, if the initial velocity of the particle is in this direction, and it is restricted by some means to be at the same distance from a point, then it starts to move in a circle. And in this case also, though the acceleration of the particle and the force are in the same direction, but the motion of particle is not along this direction. Instead, if the particle was at rest and we started to pull it in this direction, then its motion would be a straight line and in the direction of force. So the difference is due to the fact that at the initial instant, How are the initial velocity and the force on the particle oriented with respect to each other? Depending on this orientation, the motion of particle may or may not be in the direction of force. And now, for the case of non-uniform circular motion, we know that there is a centripetal acceleration due to the change in direction of velocity, and a tangential acceleration due to the change in magnitude of velocity. And resultant acceleration is the vector sum of these accelerations. So in this case, the resultant force on the body will be in this direction, such that its component along the radial direction acts as the centripetal force, and its component along the tangential direction acts as the tangential force.